1938. A young chemist opens a gas cylinder in his laboratory. It should be under pressure, but nothing comes out. Curious, he takes a saw and cuts the metal cylinder open. Inside, a mysterious white powder that no one can explain. That moment of pure curiosity changed kitchens, space travel, and medicine forever. This is the story of the slipperiest material on Earth, discovered completely by accident. Today you will discover the incredible journey of Teflon. April 6, 1938. At a DuPont laboratory in New Jersey, Dr. Roy Plunkett, just 27 years old, was working on a problem that was literally killing people. Back in the 1920s and 30s, refrigerators used highly toxic chemicals like ammonia and sulfur dioxide. In 1929, a refrigerant leak in Cleveland killed over 100 people. The mission was clear: find a safe alternative. His candidate was tetrafluoroethylene, or TFE for short. It was a colorless, non-toxic gas. He stored it at -78 degrees Celsius in 100 small pressure cylinders. But when he opened one cylinder for a routine test, something impossible happened. Nothing came out. He weighed it. Full weight, 1 kilogram. But the cylinder seemed empty. In a move that would violate every modern safety regulation, Plunkett made a drastic decision. He sawed it open. Inside was a white, waxy powder, smooth, odorless, and completely unexpected. What hours that had happened? The gas had spontaneously polymerized. Basically, the molecules decided to hold hands and form long chains. A perfect storm of temperature, pressure, and tiny iron traces inside the cylinder triggered a chemical reaction no one had planned. Plunkett and his assistant, Jack Reebok, started testing this mystery substance immediately. First, it was incredibly slippery. Nothing they had ever seen came close. Second, it was chemically inert. They threw acids at it, bases, and solvents. Nothing reacted. Third, it was heat-resistant. It would not melt at normal temperatures. Plunkett realized instantly that this was not just a lab accident. It was a sensation. He had just created polytetrafluoroethylene, or PTFE. We know it today as Teflon. So, what makes this stuff so special? It is all about the molecular armor. Normal plastics consist of carbon chains with hydrogen atoms attached. But in Teflon, every single carbon atom is completely surrounded by fluorine. Fluorine is the diva of the periodic table. Extremely greedy for electrons, it forms the strongest bonds in organic chemistry, creating an impenetrable molecular fortress. This creates 4 true superpowers. The first is smoothness. The coefficient of friction is 0.04 to 0.05. That is as smooth as ice on ice. One of the lowest frictions found in nature. For comparison, rubber on asphalt is 0.7. Teflon is about 15 times slipperier. It is so smooth that even geckos, nature's ultimate climbers, cannot stick to it. Their molecular grip just cannot find purchase on the fluorine surface. The second superpower is temperature resistance. It works from -200 degrees Celsius to +260 degrees Celsius. Normal pan cooking happens between 180 and 220 degrees, the perfect range. But if you crank an empty pan to full blast, it can exceed 300 degrees, which is the danger zone. Remember that number? 300. The third superpower is chemical inertness. Teflon reacts with almost nothing. Only 2 things can really attack it: molten sodium at high temperatures and elemental fluorine. Both are extremely rare in any kitchen. Finally, it is water repellent. Water simply refuses to stick. Perfectly superhydrophobic. You might wonder why it took 16 years to reach the kitchen after its discovery in 1938. The answer involves the atomic bomb. During the Manhattan Project in 1942, scientists needed to enrich uranium. This process involved uranium hexafluoride, a substance that is insanely corrosive. It eats through normal metals in hours. Someone remembered the weird white powder, the only material known that could resist the corrosion. Teflon became classified as top secret. It sealed valves, lined pipes, and coated pumps. Between 1943 and 1945, DuPont produced about 2 tons per month, and most workers had no idea what it was actually for. Watt-hour style, it is an oversimplification to say Teflon won the war. It significantly accelerated uranium enrichment. After the war, Teflon finally went public, but three massive problems stood in the way of your breakfast. First, the cost. In 1945, the price was $50 to $100 per pound. Aluminum was only 20 cents. Teflon was up to 500 times more expensive. Second, the processing. Teflon melts at 327 degrees, but it does not become liquid. It turns into something like thick chewing gum. It cannot be poured or molded. Engineers had to use sintering, basically baking the powder at high heat until it sticks together. The third problem was the adhesion paradox. Teflon sticks to nothing, including the pans themselves. Early coatings flaked off within days. For almost a decade, Teflon stayed in niche uses like military aircraft fuel lines or artificial blood vessels. It took a French engineer named Marc Gregoire to change everything in 1954. Gregoire was experimenting with Teflon coatings for fishing lines. The popular story says his wife, Colette, suggested trying it on her cooking pans. What horse there, it was a lucky suggestion or a calculated move. Gregoire found the breakthrough: acid etching. He developed a process that microscopically roughened the aluminum surface, creating tiny pores. Then he baked the Teflon on at 400 degrees. The coating locked into those microscopic holes mechanically. The adhesion paradox was solved. In 1956, Gregoire launched the brand Tefal, a combination of the words Teflon and aluminum. By 1961, they expanded to the United States. The marketing was brilliant. Television ads showed eggs sliding across pans like magic. Many viewers actually thought it was a camera trick. By 1968, 1 in 4 American homes had a non-stick pan. Today, it is estimated that 70% of households worldwide own at least one. However, this story has a darker side. Watt-hour style, the Teflon polymer itself is chemically stable at normal temperatures. The manufacturing process for decades used a chemical called PFOA, perfluorooctanoic acid. This is a forever chemical. It does not break down in the environment. It accumulates in water, soil, and human blood. Health concerns arose regarding workers and communities near manufacturing plants. In 2017, a major manufacturer paid over $600 million in settlements. It is important to note that since 2013, major manufacturers have phased out PFOA. Modern non-stick pans are made without it, though the science on replacement chemicals is still ongoing. There is also the issue of overheating. Above 260 degrees Celsius, Teflon begins to release fumes. In humans, this causes flu-like symptoms known as polymer fume fever. But in birds, it can be lethal. If you have pet birds, this is crucial. Their respiratory systems are extremely sensitive. Even temperatures starting at 160 degrees can be dangerous. Teflon's story extends far beyond the kitchen. In space exploration, it provides heat shields and astronaut suit fabrics. In medicine, it is used for heart valves and vascular grafts because the human body does not reject it. You can find it in the roofs of stadiums, in breathable rain jackets, and even in high-speed electronic cables. So, is Teflon a miracle or a mistake? It is both. It revolutionized daily life and saved lives in hospitals, but its industrial legacy remains complicated. If you use non-stick cookware, the rules are simple. Never preheat an empty pan, use medium heat, replace the pan if the coating is damaged, and always ensure good ventilation. We researched this history to show that scientific breakthroughs are often messy and accidental. From a forgotten gas cylinder to a global household staple, it all began with one person asking a simple question about a weird white powder. What hours at about you? How long have you had your favorite non-stick pan? If you have managed to keep one in good condition for more than 5 years, tell us your secret in the comments. We would love to hear your thoughts on this accidental innovation.